Assalamu alaikum, my dear cadets. I welcome you all. It's a very critical moment to you all where the novel coronavirus has scattered everywhere in our country and also all over the world. So, be safe and sound and stay at home. Don't go anywhere. However, you excellent are. I am Mohammad Ashikur Rahman, lecturer in chemistry at Borishal Cadet College. Today, I am going to start my lesson on chapter 2, and the title of the chapter is Organic Chemistry, which is included to your chemistry second paper. And the topic which you will be taught today is fundamental concept of organic compounds and homologous series. By the end of this lesson, cadets, you will be able to classify organic compounds. Secondly, the molecular formula and structural formula of functional groups of various homologous series. And finally, you will be able to explain special properties of organic compounds. First of all, move on to the concept of organic chemistry. The definition of organic chemistry is here, which is the study of carbon and carbon compounds. The organic compounds are the primary constituents of all living organisms, like here. Now, the characteristics of organic compounds. The organic compounds are nonpolar compounds. They don't dissolve in polar solvents like water. Because the water is a polar compound, remember the rule for that. This is likes dissolve likes, which mean polar compound dissolves in polar solvent and nonpolar compounds dissolves in nonpolar solvents. This rule is very effective to memorize how can an organic compound gets dissolved or not to another solvent. The organic compounds have low melting points due to weak intermolecular forces. Consider the following molecules: two molecules in which carbon-carbon single bond is present here, and a weak van der Waals force is present between the two molecules. They react slower than ionic compounds due to strong covalent bonds between atoms. Consider this the same molecule where the strong attraction force is shown here between the two atoms in the organic molecule of compounds. This is the another molecule of organic compounds here, and a strong bond is shown here. Now you have to know how to draw an electron dot diagram of carbon. First of all, you have to write a carbon at the center and then its 4 valence electron right in a dot point like which is shown here, and As we know, carbon has 4 valence electrons. So carbon is able to form 4 covalent bonds with other carbon or other elements, which is shown in this diagram, which is dot and cross diagram. Now we will consider the structural formulas of organic compounds, how it can be written. A 2D, that means two-dimensional model, shows bonding patterns and shapes of molecules. First of all, carbon is found in the center, and secondly, the short line represents a pair of electrons. Consider the following example where carbon is placed at the center and its bonding site is placed around the carbon atom, like here, and finally it is covalent bonded with 4 hydrogen atoms and form the structure of organic molecule. Okay boys, now draw the structures for each organic compound. Consider the first molecule, that is methane. First of all, you have to place the carbon atom at the center point, and then its 4 bonding site is placed around the carbon atom, and then finally it is bonded to 4 hydrogen atom, like here. Similarly, in the same way, chloroform and ethane can be written in the same way. Remember boys, carbon has 4 bonding sites in every time. Now we will consider the different types of bond in organic molecules. First of all, the single bond. When the 2 carbon atoms are linked with a sigma bond or single bond, then it is called the organic compounds containing single bond molecules. Here the single covalent bond share 1 pair of electrons, like here is shown. And boys, you see, this is the sharing electrons of the organic compounds, which is shown here at the middle side between the carbon atoms of the organic molecules. Now the double bond. In this case, carbon atoms may share 2 pairs of electrons to form a double bond, which is shown here. Here you see that the 2 carbon atoms share 2 bonding electrons, which is placed at the center between the 2 carbon atoms of the organic molecules, and then the triple bond. In this case, the carbon atoms may share 3 pairs of electrons to form a triple bond, which is shown here. Boys, you see the triple bond formation of an organic compound. In this case, the 3 pairs of electron is shown here between the 2 carbon atoms of the organic molecules, which is designated by a circular circle. Now you will learn the different types of compounds depending on their saturation. First of all, the saturated compounds. In case of saturated compounds, single bond is present in organic molecules like methane. In case of methane, we see that methane contains 4 single bond. Here is shown below. Then the unsaturated compounds, in this case compounds containing the double or triple bonds. Consider the example of ethane, where a double bond is present between the two carbon atoms of ethane molecule. Now we will learn the homologous series of hydrocarbons. Boys, do you know what is homologous series? When the compounds of the same series are arranged in order of molecular weight in increasing order of carbon atoms, it is observed that the adjacent members differ by a CH2 unit. They exhibit gradual variation in physical properties and show similar chemical properties. A homologous series is a series of compounds in which adjacent members differ by a CH2 group. For better understanding, I'd like to share a short video clips on it. Okay boys, let's get started.
The element carbon is like a treasure box. It holds various interesting mysteries. One such unique concept is that of the homologous series. What does it mean? Let's understand this in detail. Let us get to know the concept by breaking it into two parts: homologous and series. One thought we might have is that it refers to some series having similarities. Is it true? Yes, absolutely. In the first part, the word homo refers to same. So in the case of homologous series, we will have compounds that have something in common. But what is common? Here we are referring to the common functional groups. What about the next part, that is series? For being in the list of homologous series, the compounds need to occur in a sequence. That means they will occur in succession. And what do we mean by this? Let us consider the simpler alkanes like methane, ethane, propane and butane. Are they in succession? You may say yes. They occur one after the other. But what exactly makes them successive to each other? To understand this, first tell me what is the molecular formula for each. The molecular formula of methane is CH4. That's right. Ethane is C2H6 and propane is C3H8. And how is butane expressed? Its molecular formula is C4H10. Now what will happen if I add CH2 to the molecular formula of methane? It gives me C2H6, right? That is ethane. And if I add CH2 to the molecular formula of ethane, does that give me propane? Yes. Adding CH2 to the formula C2H6 gives me C3H8, which is nothing but propane. And you know the last one. Adding CH2 to propane gives us C4H10, that is butane. Now can you tell me how exactly these compounds are in series? Yes, they are in succession. And what is the common functional group among these compounds? Needless to say, it's an alkane. That means the compounds here will have the same general formula. For example, In this case, the general formula for alkanes is CnH2n plus 2. So all of these compounds show this typical general formula, right? Yes, they do. Even though they have different molecular formulae, the general formula is the same. And we also noticed a common difference between any two successive compounds. There's a common difference of CH2. Now that we've understood the concept, let's define the term homologous series in simple words. It is the series in which the compounds with the same general formula but different molecular formula occur in immediate succession. So the hydrocarbons in the homologous series will have different lengths of carbon chains, but they will possess the same functional group and will occur in succession. Now tell me one thing, if these compounds are in series with the same functional group, don't you think their properties will also be the same? Well, if you said yes, then you are apparently wrong. Because all the properties of elements in the homologous series are not exactly the same. The chemical properties are definitely similar as they are dependent on the functional group present. However, the physical properties show gradation as we go higher in the series. That's because the physical properties like the boiling point, melting point, solubility, and so on differ with the change in molecular mass. For example, a compound with 10 carbon atoms will have a higher boiling point compared to a compound with 3 carbon atoms. That's because the energy required to break the bonds will be greater. This is how compounds in the homologous series slightly differ from each other in spite of being in a sequence. This was about the concept of homologous series seen in the carbon compounds. Let's talk about another interesting concept of isomers in the next video.
Now, I would like to show this chart of homologous series of different organic compounds. This homologous series is very important to write the name of different organic compounds. Boys, here I have taken at least 15 homologous family among all kinds of organic compounds and their homologous series. Now consider the homologous series of different organic compounds. The boys, this series is very important to write the name of any organic molecule or organic compounds. So you have to memorize this chart very carefully. Here I have included at least 15 homologous series among all kinds of different organic compounds. At least you have to memorize first the UPAC name of different organic compounds. Otherwise, you will be abortive to write the name of different organic